Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say, no good deed goes unpunished.
How do? Everything okay? I'm rushing around. Give me a second. Gotta go and answer the door. Right, back. The door's gone. Cut me to the quick. I haven't finished the little metalwork rework. Anyway, so welcome to another one. 7-band HF antenna switcher, Exoskeleton Aluminium. And I'm just wondering whether some thick foil off one of those baking things would do the trick. Anyway, save a lot of hassle. Right, so I just caught me filing some of this aluminium. So let's just have a look. We've got lots going on here. I've just been filing and opening the holes up. Let's have a look at it then, see what we got. Let's make sure we've got some audio. Caught me filing some of this aluminium. We've got audio. I'm not sure how good it is. I need to work on that a bit. So anyway, right. About 2 o'clock I started creating the G code for these aluminium pieces. So I've done the base aluminium. It's 1.2 mil thick, and I've done the top lid. All I had was a blunt million bit, so I've had to do a bit of rework. Here's the strip. Just caught me finishing off, sanding that edge down with taking the burr off with a needle file. And it went a bit wrong because I was told it to mill out 50% around the edge and put a fold in, like a crease, so I could bend it. But I don't know what happened. My bed is not straight and it started cutting it out, so something went wrong anyway. So it's going to have left me with having to bend this somehow. Crease it. I'll try and crease it both sides and then bend along it, but really it wants making again. And also it started to come adrift there and it milled into that little bit there. So I've gone round it, all the holes with a drill bit, and just tidied them up a bit. Some of them didn't drill through all the way. It's difficult to do when you've got a very thin piece. It's probably easier with a thicker piece. Anyway, so I've just took the edge off and I've just got a little bit more to take off there. This edge just came out rough. So that's what got me thinking there's got to be an easy way. Or maybe get rid of this piece altogether and arrange the drawing. Go to the drawing. So let's just hide the alley strip. So almost you've got the metal already here. Look, see the metal. This is already metal. So the only reason I want the strip is to basically attach it to something. So you've got the aluminium strip, chassis aluminium. So if I could redesign it, because this is a pain to make. This strip is not easy. So wouldn't it be better if we didn't have to make that strip? But anyway, maybe next version we'll have a look at that feasibility of it. So if you could mount these very close together so they touch, and the lid, without the plastic clamps, chassis clamps. So if I get rid of the aluminium, got rid of that. Get rid of the SO239s. So we've got these plastic chassis clamps. What about if we redesign it and make it fit? Just so happens, so these SO239s take up the gap here and all the way down, if at all possible, because they're already metal. Then we wouldn't need this strip, and I wouldn't have to sit here shaking the edge off with a needle file. I'm just going to finish that off. Let me show you the other bit. So I went ahead and built this up. This is the plastics and the knob. So you got your knob turner, just pushes on, and then I've got the snappy motion inside. And it snaps into position. Then I got me thinking, do I need a PCB at all? Because you could, let's just take the lids off a minute. Where's it gone? Let's just take the base, I'll leave the base, top lid aluminium off, 239s, let's get rid of the chassis clamps. So you've got these, hang on, bring the base plastics back. So hide the PCB. So these brass inserts are melted in. I've actually gone ahead and done that. So this, what about if your incomer, which is this red one, if your incomer there just went straight over around this, maybe if I put a spiral around it so a wire could wrap around it, so you'd have to limit the ability, to go round in a circle continuously. So let's just get rid of it a minute. Everyone's doing contesting at the minute, so let's get rid of them. Yeah, a lot of people doing contesting. I've aided them a bit today. I've given them a few shouts. There's nothing much in there. Let's turn that one off a minute. Right. Okay.
Ryanair 72 Yankee Yankee, London Control, good evening.
Let's leave that on. Right. So what about if I soldered a solid core wire round to this and wrapped it round here, then came out to a copper prong, just like a flap wheel. Hang on, let's turn that off a minute. So came out to a flap wheel here. So this came out, and we had a brass stud there, like an M4 brass pin or M3. So that came out to there, wrapped around, and came out to this copper prong or copper strip. So when you turn it, and the cable from the incomer is jointed into this. So pretend that comes out even further and it's on vertical instead of horizontal like that. And it just went, and these studs were in place, fastening that centre part of the SO239. So the tenter core down to this with a ring crimp with a brass stud. So this would then touch the brass stud, and when it's centered, the brass, the copper piece is under load and it's directly on it, so the brass stud will be sticking up, and the copper strip would be slightly bent against it to make sure a good fit. But anyway, that's just an idea. It's just an idea, just to get rid of a few complexities. But what I'm going to have to do ultimately is some continuity tests, run some amperage through it. That's what we're going to have to do. Do a continuity test first, and then actually put either some voltage through it. I could put some voltage through it with an insulation tester, or just try and run a few amps through it. Yeah, put dummy load or something. Don't run any RF power though. Just don't test it on your radio. Just put say 12 volts to a automotive bulb or something like that, and a bit like the old school dummy low where you use a bulb, and just put your 12 volts in, or whatever you want, 24 volts, and then keep switching it, and then you can monitor the voltage output, see how reliable it is. Anyway, so there is that to it. So now what I was thinking, to get rid of the chassis aluminium, this piece here, is forget about that altogether, and to get these to, you'd have to go in further. So you'd have to, let's just say if we move one, can we move it that way? Yeah, we can go, so if I move it 10 mil and then move this one, hang on, it's going to have to be done in a certain way. 10 mil. Now I'm not going to do it there, but see how they're touching. They're too close, so I'd have to come back. I'm just looking at the feasibility of it. Hang on. Now, so I'm going to have to undo that. Undo move. Undo setting put. Right. So if I put this one, say, it's not wanting, is it? Oh, there it is. So if I say 8 mil, and because the plastic can hold it all together, and say 8 mil, they're just touching now, aren't they? Just a little bit. And when you screw them to get to the plastic bracket, obviously the bracket's going to be in the wrong way now. That's going to have to be remade and smaller. So if I say, yeah, so if I undo them two, let's say we're going to move them, we tried 8 mil. Let's say they're going to be, I don't know, 7.5 mil. Oops. 7.5 mil. 7.5 mil. So you want them just where they don't, yeah, it's just, that's close enough probably. Close enough. So I just want to go a little bit more, but imagine that, then it would be even smaller, but it's in the arrangement of this. And you could go more way if you wanted. You could actually go more way. You could go 8-way with a feeder if you wanted to keep the size. Anyway, let's put that back where it was. Okay, So that's back where it is. So there's all sorts of ideas to simplify this. Use the structure of these to build, to attach to. I don't know why I didn't think of that before. It's no bother to print these out, although I have put the inserts in. Doesn't matter, I've got some more. So anyway, come back to the real thing. So I've got this thing here which I built. I'll just take it apart. Let's get a screwdriver on it. Just take it apart. So the light's shimmering a bit. So just take these out. These are just some M3 screws. Alright, let's just take this apart and can have a look inside. So I've also got to take it apart to put this strip on anyway. And it does line up, but what happens when you bend it? So, you know, we're going to have to bend it. So we could do without making that bit, if you know what I mean. Let's take this apart. What life? Yeah, so just milled it out. Last 2 hours milling that out. Well, I've slowed it down. I'm supposed to be having a battery delivered today. They said, oh, we'll deliver it between 4 and 5. It hasn't turned up. So. DPD, that is DPD. They build your hopes up and they don't deliver it. Oh well. Wasn't supposed to come till next Wednesday anyway. Right, so I've got to take this off. So you've got the little spindle in there. Don't know whether I showed you this last time. So your spindle just pops out and you've got this kind of thing. And inside there you've got your nodules that are able to snap into position. So if I put that on, put the knob on while it's without the cover, you can hear it. You can't see it with my hand in a way. Anyway, let's build it up. So what I'm going to do is build it up. Let's build it up. So put the plastic back on. And we've got the aluminium to go on as well. Plastic on, then the aluminium. That's your screen basically, and I can screw that back in for now. If it's thick enough, should be. When I put my hands down, you can't see what I'm doing. Alright, so that's going to go in there. So we'll call this revision 1. And we had to build it to you've got to build it to visualize it. So oh, that was my screwdriver on the microphone, sorry about that. Right, so you build it to visualize it, and then you have to make a new I don't want to make too many revisions, but there's no avoiding it, I don't think. No avoiding it. Anyway, I'm putting all this on, but it's going to have to come off to put this strip on. But we still haven't got the SO239. So anyway, I'll just put it back together. I just want to see how it clicks. I just want to see if it clicks okay and behaves itself, and get the gist of the weight and that. So I'll build it up, put a knob on. And I also got to design a pulley wheel as well, a belt driven pulley wheel. So I'm going to base it off CNC belt. Just so we can remotely switch it without interfering with the electronics. Well, without the electronics interfering with the switch and the RF. Okay, so we've got a bit of metal on it. I can put the knob back on if you like. There we go. There you go. Seems okay. Let's put the base on. So you've got the shaft keeps it sturdy in there inside the plastic. So it's actually turning. I don't think you can see it, but anyway, let's unscrew this and put the base plate on. Aluminium base plate. And what I've got to try and do, see if it's worth trying to bend that strip round and fit it. I'll try and bend it and see if it'll actually go and line up, but I'm a bit worried because I didn't manage to score it, that it would bend in the right place. So I might have to, with a Stanley or something, or just try and score it all the way around both sides where it needs to bend. Right, let's just get this last screw out. So the plastic's acting as a chassis, and you bolt all your metal, aluminium, onto the chassis, and that's for your screening. Well, I reckon if we there we go. So that piece got to go on like that. I reckon if I make another design, might do that later. One that doesn't need this strip making. Don't need the strip. Make another design that doesn't need the strip. I think we'll use the because we already got metal. Comes with the SO239. So in that case, why have another piece that you don't need? If it's only for screening, that's all it's for. It's for screening. The metal is just like a ground and earth around it, just for screening. Because you can't have plastic as a screen. So anyway, they're just ideas. Alright, so getting an idea for the weight on this thing, and it's quite small. On the screen it looks a lot bigger than it is, and it's just a dinky thing. If I use this SO239s as the structure, it's going to go even smaller. Doesn't really matter as long as there's a way of switching it internally. You know, so it's better if, because obviously going to put the whole idea with doing a PCB was to put relays in it. But then I found out after that the relay coils can interfere with the signals, so you have to have special RF rated relays that are expensive. Yeah, so you can hear that. What I should have done is put a little bit of grease in there, I suppose, really. Right, so the next thing is this strip, but I haven't quite finished it. So what I'm going to do, that's already got a bit of weight to it anyway, that has. It's alright now. So what I'm going to do is just finish off filing this, then I can bend it. Alright, let's just do that, and I'll put you on this one. Right, let's just get rid of these burrs, because I've got to do all this filing, you see. It doesn't matter if you can mill it, but you're still going to end up having to file the burrs off. So I'll just get these off and I can see how easy it is to bend. I was doing that just before the live stream started, and I ran out of time, so there's just a bit left to do. Didn't want to keep people waiting. So anyway, Right, is that it? Almost. Right, it's rough as hell, the one edge. I think I had a bit of chattering on my CNC, the one edge. So anyway, it's just a test one to see if it'll work. But I think I like the idea of the SO239 metalwork being the chassis, just being held together with the plastic at close enough quarters that it just acts as a screen. So yeah, it's a screen anyway. Yeah, because I don't want to start sanding this down. But you could send this design off to PCB Way or something like that. I don't know how much they'll charge, but they'll put it on their professional CNC machines and let them have all the trouble. But I don't know how cheap it is. We could tell you what, we could upload the STL file and see how much it costs as a, just a demo, just to see. Save all this messing around. But anyway, if it's going to cost too much, you might as well just buy one. Buy a ready-made, if there is such a thing as a ready-made. Right, anyway, that's enough for now. Right, let's see if it'll bend. So I've got this thing, there's a few problems with it. Now, it's supposed to have a line there and there, well, scored halfway through. Now, if I bend that now, it's going to want to bend on the weak bit. So I'm going to have to put it in a clamp. So basically, I'm just wondering whether we could use this as the bending, the shape. So if we fasten it one end with the pins, and then bend it round slowly and keep bolting it in. But it's going to have a crease. Definitely going to have a crease. So I've got to work out how I'm going to do a crease on it. If we go down this route, if we go down that route, or do we just cut, cut to adjusting this and have to make a load of new plastics? I'd have to remake this. I've to remake that. I've got to remake this anyway because I've got a problem here. This is not the diameter. Sorry, that diameter is bigger than this cutout here, so that's the problem anyway. And the plastics, I'd have to do all the plastics again. Not a big deal. Yeah, so it'd only have to go in a bit. There is room to do something with it. Anyway, we can't start all over again, otherwise we'll just keep restarting all over again. So what we'll do, we'll finish this one off. Alright, so I've got to work out how am I going to score that now. I could go and stick it back down. It's not easy though. And then lightly score it with a CNC. Probably a V-bit. Yeah, change it for a V-bit. And line it up and just manually go back and forward, or create some G-code. But it's rough anyway, that bit's rough there. It started lifting that. Just make the top and bottom is made out of the same stuff. Or I put it in a clamp, try and push it over the edge of a table or something and bend it. Let's just try that. No, it does need a crease in it. Anyway, the mechanism worked okay. The only trouble is it's having to go through. If you go onto the drawing, it's having to snap on all these. So there's loads of them to snap against. But what it does do, it does ride up over top of it, and then when it goes into the hole, it relaxes. So this slightly takes up the play as it's doing it, if there is any play. So where do we go from here then? Let's have a think. Do I modify what I've got? Let's just go through the feasibility of getting rid of the aluminium. So we put the chassis clamps back on. We still need the aluminium down below, and the top aluminium, plastic and aluminium. So this aluminium would have to be flush with this, and that bottom one would have to be flush with that. That's okay. Your size at the minute is 31mm, so it would literally we'd get rid of 6mm, so it'd be 27mm. No, less than that. So do I go ahead and alter this one? The only thing is that aluminium. I'm just thinking, do we need the plastic then? We need the bottom plastic, yes. And do we need the top plastic? Because you've only got between there and there, so yeah, because your fixings have got to go somewhere. That's the problem you got. So your fixings would have to come through, and there's not much space to start with. Not a lot of space. So put your chassis aluminium on. See, the chassis aluminium, do we need that? That was going to be the structure initially, but now the clamps hold it all. They clamp to the SO239 panel chassis socket, so they hold each other together. We've got all the stuff here, so we could easily modify it. I would have to build a new bottom. That's okay. I'm not sure whether we need all this many. Oh, we do. Yeah, sorry, we do. You will need them. Not necessarily the pegs. You need the holes, so you need a stud that it'll snap into, as long as it snaps into one of them. So at the minute I've got a peg at each one. Yeah, so it's okay. Maybe it just wants a bit of lithium grease or something, or silicon grease, something just there to help it to go. I mean, it's okay. Just feels a bit grindy. I suppose I'll take it apart and put a bit of grease there. Yeah, I suppose let's take it apart and put a bit of grease on it. And what have I got grease wise? Not a lot. Oh, I've got some spray stuff for a bicycle. That's no good. Anyway, I'll leave that bit. I can come back to that bit. So let's explore the feasibility of getting rid of this chassis aluminium. I'll have to redesign these, which I've got to do anyway. Actually, they do fit there according to that. What's different? What have I done with that? Hole definitely doesn't look right. Let's measure it. So I've got 14mm there, and 17.5mm there. So yeah, they need to be altered anyway. So basically, if I measure from there to there, got 15 mil, and on the one without 17.5 mil. Yeah, so they're not quite right, but I have allowed a little bit space extra, so they might well still fit. But anyway, so if I brought those two together, all them together, if I brought them all together, because it could be as the height of these. How would I fasten them? Let's just get rid of the shaft a minute. Shaft gone. No, actuator gone. Wiper gone. Let's just have a look here. So if I join those two together, bring them in, remake these clips with a sharper angle, then I've got to fasten the body. Definitely need these two, but then we won't have enough with the to bring that aluminium up to there. That'll get too close to where the nut fits, so that ain't gonna work like that. So at the minute the chassis aluminium is just gonna get rid of this extra bit. Get rid of that, and yeah, so probably wouldn't work because we need the structure here in 3D plastic to do all the switching. The aluminium needs to be the screen like that. So it's just that strip was very difficult to make. That strip, so if I hide, yeah, so this strip is not easy to make, but my milling didn't actually put a crease in it. I could have put the crease in first. Something happened to my sizes, I don't know what. Yeah, something happened. I created some G code. This is the G code I did, and it did the cut the holes out, inside cut on all the holes. Then I did this one. I never got to that one. I did this one, and for some reason, it's put a line all the way around it. Yeah, it's put a line around it. It should have only done these, then that should have cut it out after. So I could try it again with a different milling bit. That was a 2.8 millimeter 4 flute end mill that I milled it with. Or we could go thinner. What about if we go thinner, even thinner? That's as thin as aluminium I've got. I haven't got any thinner aluminium apart from, yeah, tin foil's no good. You can get thick tin foil, but probably not a good idea for wear and tear. So that's why it ended up milling it, but it should have only done 50% of the aluminium thickness, which the material thickness is 1.35, 1.2, and I made it cut slightly over. A bit diameter is 2.8. Generator multipass 0.2 millimeters. So it took about 7 passes to cut through it. But with it being thinner, my bed is not level that accurate, so you end up with problems. Yeah, so anyway, that was the G code for these two plates as well. Like I say, you could send them off. Yeah, so you could send them off to PCBway or something. But you know, they got better machines. They can mill it out properly. You know, very accurately. Yeah. I can laser cut plastic, but a 40-watt laser wouldn't touch aluminium. It would probably just take an anodize off. It wouldn't. You can't cut aluminium with need a fiber laser or something like that. Anyway, so let's check the feasibility of doing it, the actuator in a different way. Right, so the wiper back. So the wiper's this spring-loaded thing that snaps into the shaft. You can't see anything. Why not? Let's get rid of this chassis a minute. And the chassis clamps. Yeah, so it just pushes into there. But you've got to touch onto a PCB. But if you had a brass stud here, let's make a brass stud. They're M3, aren't they? So let's make a brass stud. Let's just make one here. So 1.5. Let's say they're 5 plus. Let's make it 16 mil. 16 mil. Let's make it a component. Let's lift it up a little bit. Right, so if you screw that down, you'll have a nut on it to hold down the ring crimp. Okay. Okay, you want a top to it. Let's say the top is, let's say it's 4. That looks a bit too much, doesn't it? Hang on. Let's say it's 3 mil. Okay, let's make it round. Probably like that. Let's colour it. Okay. Alright, so we've got this pin. So we want to look at it in X-ray mode. We'll grab it from there and stick it over there. Not from that angle, we won't. Let's find a different angle. Oh yeah, can't find it. I think that's it. Right, so let's just put that in there. Let's screw it down. So we need to go down 5 mil. Right, so we've got this thing. We're going to need a nut as well, a brass nut for the ring crimp. Right, let's create a brass nut. It wants to be, so it'll be 8mm plus, let's just say 8mm, 4mm again. It needs to be about 3mm again. 3mm, yeah, 3mm. Oops, what happened there? Right, let's get the nut, make it into a component and move it up. Okay, and then that's the wrong tool. If you're going to make a nut, you might as well make a nut properly. Might as well do a good job of it. Okay, let's colour the nut. It's a brass nut. Brass or copper? Brass. Does brass conduct? Should do, shouldn't it? Or has it got to be copper? I don't know. Should be able to conduct, I would have thought. There's always a few bits that you haven't coloured. Okay, so we've got our nut. Let's come out of it and grab it by... I need the X-ray mode again. Let's do it from up here, it's less cluttered. Okay. So that'll go there. There will be a little bit of a gap. Say 1mm. 0.75mm for the ring crimp. Okay, so we've got that. So aside the shaft a minute, and the wiper. So we could do with copying this all the way around now. How do it? Hello David, Jordan Bath, how you doing? Sorry I missed you there, mate. Are you okay? There you go, and we also got Andy Crowley. How you doing, Andy? Is it looking there? Is it? Oh, sorry, I'm dyslexic. It is looking there. Right. I'm not sure what that means, but I don't know. Let's say hi, Andy. Welcome to the live stream. How you all doing? Yeah, making a HF switcher. A switch, radio frequency switcher for the HF band, high frequency band of AM radio. Because these switches are notoriously expensive, and I want to be able to switch it from a belt driven stepper motor. The stepper motor is not nowhere near it. It's on the end of a belt about say 500 or 600 mil away. Looking good there. Right, I'm sure you'll bring it into work when it's finished. Yeah, we've got to show it. Yeah, they'll just yawn if I show it. You won't, but if I show the gaffers, they'll just yawn at me and they go, oh, like that. Yeah, I don't know. Anyway, it stops me eating. That's the main thing. Stops me binge eating. Because when I'm streaming, I can't leave it long enough to eat anything. You can't even stop for a biscuit or anything. So it's one way to keep the food down. Yeah. Welcome to the live stream. Anyway, that's Jordan. It's a colleague I work with and a friend. He's a nice lad, very nice lad. He's into his air guns, BB guns, is it? Or have I got the wrong thing? Paintball guns. So we've got a project on where we're going to one day take his broken paintball gun and create a 3D printed enclosure to fit a universal equipment and write the little firmware for it to actuate the solenoid so we can, instead of when they break down you've got to keep buying a new one, you can replace it with pieces. Anyway, let's get this as a group. Let's group that, and now I can't remember how to get from one to the other, so let's have a look. 16.544. Well, we won't do it that way. We'll grab it like this, and we've got to copy it first. Hang on, copy it, paste in place, and then we should be able to move it 45 degrees. Where's my? Hang on. This is awkward, isn't it? It's not snapping to 45 degrees. Where's my 45? There it is. Right, so they can move that. Let's find out. 45 degrees. Let's paste another one. Let's go the other way, 45 degrees. And paste another one. Let's go 90 degrees. Paste another one and go 135 degrees. Is that the next one? Let's have a look. Yeah, 135 degrees. And if you want to be really clever and do the last three all in one, we can do it like cheat a bit, save some time, and we want to start from somewhere, bring it round 135 degrees. There we go. I saved a bit of time. My son is asking why you have a square TV in the background. Yeah, because I'm a Amiga freak. I'm an Amiga freak. This place is like a bombs hit it at the minute. But I've got the case I built polycarbonate or acrylic case for the old computer, and we've got an old square monitor, CRT cathode ray tube monitor, an old computer. These bits here, you're looking at £1,000 worth of stuff, and you got the old Amiga 600 in a modern case, or relatively modern, and that is probably worth £500 on its own. And I've got over here some retro computers full up of retro stuff, and this isn't not even the half of it. We've got about, I don't know, 20 tubs of this full of retro computers and stuff, which have got to be recapped at some point anyway. Yeah, so we've got all sorts going on here. It's yeah, bit of a mess. We've got a room view cam. I can give you a room view a little bit, and you can see the craziness in here. Sorry, it's shaky cam. There's my radios and all my other stuff. That was supposed to be my music computer with the speakers on the stands. Anyway, that's it. That's all I got for today. No, it's not. Yeah, it's crazy. It's crazy, that. Ugh. Let's put the camera back and leave it alone before I knock everything off. Yeah. Right, anyway, so let's get back on this. Yeah, the computers, them old computers, that's what people used to have. There was no such thing as a flat screen TV. The closest you could get was a Sony Flatron, is it? Or something like that. Anyway, so we've got our studs, so let's put the shaft back. So we've got this thing that turns with a thumb turn on the top. Now what I was thinking, instead of having the wiper like this, so basically your SO239s, they're soldered there and they come out to a ring crimp and they're bolted underneath there, right? So that is then like a pin that a metal copper strip can then be attached to here, and all it does is it flaps against the side here. It touches the side, but because we're pointing straight to centre, the flap, sorry, the metal copper strip would be loaded against the pin. It would be touching the pin because, or it could even touch up here, the side of this, or the side of the nut. But because it's trying to point directly to the centre there, it will be slightly bent, and the natural sprung loadedness of the pressure would make the contact. Yeah, it would make the contact. That is the idea. So, well, what I was going to do is I was going to have a PCB. So make this PCB. Imagine, let's just hide these a minute. Let's give these a layer to sit on so we can hide them if we want to. Oh, what have I just enabled? So have I just got them? Yeah. No? What have I got? I seem to have everything. Why have I got... Oh, hang on, let's start again. I must have done something weird. I just need to put them on their own layer so I can make them disappear. So let's create a new layer. So pins, there's some kind of let's just say pin, conductive pin. Right, so I put them on the conductive pin layer. If I can find it again, there it is. So I can turn them off. Right, so we need the pins. Now if we're having a PCB, then we'd have a shorter pin. So let's create a shorter pin. So we'll copy that. Copy it. Where's the copy command? Up there. Copy. Right, let's just paste it in place. Make it unique so we can modify it. Oh, hang on. What did I do with it? Hang on. Right, that's not the right one. Don't get rid of that one. That's it there. Right, so we want that one. We're going to make that unique. We already have, but have we? Yeah, made it unique. And I need to shorten it. So this is going to just be needs to go in 5mm and then clamp to 6mm. So basically, it just needs to be. It's a 16mm. It's not an M4 brass pin, but it's an M3 brass pin. It looks like the cyclotron of a proton pack out of Ghostbusters, right? Yeah, it does. But this one here, this looks like a little miniature satellite. There's the one I did it a while back. That one looks like a satellite, a mini satellite. Yeah, this is the thing I've just been milling out. So milled out the plastic, 3D print. Sorry, milled out the aluminium, 3D printed the plastic. Anyway, so the idea works. So we want this as 6mm, and we've got what we got here, 16mm. So we need to move that 16, so 10mm back. There we go. Right. So we need to move that down 10mm. No, that didn't work, did it? Oh, it might have done. Let's have a look. Oh, it's gone a bit too low, hasn't it? Why has that gone so low? Oh, I know why. Because I didn't allow for the thickness of the PCB, I don't think. Which is 1.6mm. Oh, yeah, 1.6 plus 1mm for the ring crimp. That's it. Anyway, so now we know what we need now, don't we? Right, let's get rid of this shaft and actuator and the wiper. Let's get rid of the SO239s. So we need to copy that again and go through all that process again. I'll tell you what, let's get rid of the PCB a minute. So we want to copy that, paste in place. Let's see how quick we can make one. How quick can we get these to go around then? Now, what's that doing? Right. Oh God, what's it doing? Oh. I don't. What? How come I did it before and it was fine? Now it doesn't want to do it. Why is it not finding my? It's giving me the pink. It's not giving me. Okay, I'll start from there. Tell you what we'll do. We'll go around 180, and we'll keep doubling it. That's it. We'll keep doubling it. We'll keep doubling it. Oh, that went wrong. It snapped. It changed its position. Oh, now I've moved the original. Okay. Copy. Paste in place. This is where it gets a bit pain. Okay, now we want another get them all. Yeah, I forgot to copy and paste them. Paste them in place. Okay, this should be the last time now. It's not snapping. 45, there it is. Right, so we've got them all. Okay, so that's it. That's if it's a PCB. And yeah, that's if it's a PCB. So you solder the pin in there, come out to a small bit of wire and a ring crimp, bolt it down to the PCB, and that's, you've got this way of doing it with the shaft and the actuator, and it's like a relay contact. Not sure how good it'll be like that, trying to push down on it. It's sprung loaded with a spring at the back of there. There's a spring holding the two apart, but anyway, it might work, it might not, but it means I'll have to make a circuit board, or you know, I could make one. I could isolation route one out of double-sided copper clad. I could do that way, but that's a lot of work. Or we could send them off to JLC PCB or PCBWay and get them to make. They'd probably make 5 or 10, and if it's a prototype, you probably might change the design and end up not using them again, throw them away or nothing. So I quite like the idea of the pins, so let's put these on a separate layer. I'll tell you what, I'll put them with the PCB layer. Let's just put them with the PCB. Alright, so if we get rid of the PCB, we get rid of both. Okay, so right, so bring back the conductive pins. Still clamps the ring crimp down through the bottom of there, and you've got the pins that so we need to change this actuator to a different type. So I'll tell you what, do we make one that's quite thick, that is, or is it 1 mil thick? Let's keep it like that. So let's copy that, paste in place. Let's paste it over here. Let's change the design, make it unique. Oh, I'll tell you what, let's just get that bit there, copy that out, paste in place. Let's get rid of that one. Don't know why it's got all lines on it like that. See that? Did that once before as well. Alright, let's undo. Hang on. Undo, 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 undo. Yeah, I don't know why it did that. It did that before. Cut. Paste in place. Let's put that out of the way. Let's get rid of this one. Let's turn this on it. Let's make it unique. So we could, yeah, turn it on its side. Turn it on its side. Okay. So it needs to be longer, obviously longer. How much longer? It needs to touch the side of this. So can we measure from there? Not easy. Tell you what, let's just make it 10 mil longer. So we've already made it unique, so we can just make it 10 mil longer. Okay. Let's keep it like this angle. Oh, what's happened to that? I thought I said it was unique. Hang on, it's all gone a bit wrong. Hang on. Keep thinking I can drag that and I can't. Right, so we've got the original one back again. We can get rid of that one. Right, make it unique. That's okay. Let's make it, I don't know, 12mm longer. Rotate it. There's the blue. Right, so I need to turn that one off a minute. I need to call this new one something. Flap wheel, I don't know. Contact flap. Metallic copper strip. Copper strip. Copper strip. Where are you gone? There we are. Right, okay. So let's grab that now. Put it somewhere, I don't know where. So it probably needs to be in the middle, I would have thought. I don't know. Don't think we need that again. Let's get rid of that. Okay. Bring back the shaft. We're on the wrong angle here. It wants to face this way, doesn't it? 85, 90. 90mm. Getting lost inside the let's just get this up here. Right, so we're sort of where we want it. It's way too long. Oh no, it's got to go in there, yeah, hasn't it? Right, so we might need a different shaft here. Yeah, let's try a different shaft. So we're going to copy the shaft, paste it in place. Right, so we're going to call this one, what are we going to call this one? Don't know. So that's the shaft. This one's going to be called the copper strip shaft. Copper strip shaft. We have to make it. Hang on. Is it already unique? Ah, it's with another one. Right, let's hide the copper strip shaft. Hide the shaft. No, it's still. Right, let's get it. Got to copy it. Hang on, that's not the one, is it? That's the one. Right, so we want to go into it. God, hang on, let's put that, cut that. There it is, paste it. Hang on, go in. Paste it in place, alright. So that is the shaft, but it's now got to be made unique. And it's got to go into the copper strip shaft. So that's one, so we can hide the original shaft. And we go into this, and it's already unique, so we can alter that to. So we want the strip to be in the middle. Yeah. So it needs to be able to push in as well. How is it going to stay in unless we glue it in? Anyway, let's put it in the right place. We'll worry about that after. So, no, that's the shaft. Leave the shaft alone. So that's that. What's the 1 mil? So we need to move it over 0.5 of a mil. Then it needs to go in all the way over to there. 8 mil. So push that in 8 mil. Right, now this obviously the sides have got to be adjusted and that, but that'll do for now to get the idea of whether it's going to work. It's probably too low, it needs to go to the top. 1.6 mil. So okay. Right, so we've got this strip. Now you probably don't need this if it's going to be a copper strip. So we'll get rid of that off there. Okay, so we've just got a copper strip, plain and simple copper strip. Okay, now it's a bit lower than we envisaged it. Needs to come, yeah, it's going right through there, so it's not showing a bend, which is normal. So it'd be nice if it could hit the side here or there. So it needs to definitely come up a bit. So right, let's go back into this one and grab all of that. No, it's not grabbed everything, has it? Let's grab all of that. Yeah, oh, no, we've got a hole at the back as well, so we don't want that. Let's try again. Yeah, we just want that, and we want to move the whole lot. I don't know. Let's guess. Let's say 15 mil. That's probably too much. Yeah, it's too much. Okay. Right, we should have measured it really. Let's just drop it down. Drop it down. Let's say drop it down 7 mil. Right, okay. This one needs to go up 8 mil. Okay, we're still a bit too high, aren't we? Still a bit high. The problem is this will be, yeah, this will be threaded. It's probably not ideal, so maybe it needs to hit this. I don't know. Hey, I've just realised something. Look at that. This sticks out. So that could just touch that, couldn't it? Well, that's your feed in. So you'd have to have a cable from there to the back inside here. And you could just, these are going to come forward anyway on the next model. So you could just touch the end. That seems a bit crap though, doesn't it? That seems a bit crap. Yeah, and if it touched it, you'd have to wipe past it. It's got to be sprung. I don't know. Anyway, it's all madness. It's all madness. Just save what we got. Anyway, I gotta have a sip of my old drink here. Oh, got a dash, George. Okay, Dave, family want to watch Harry Potter. Well, I can't compete with Harry Potter, mate. Have a good week. See you Monday, yeah. Nice one, George. Thank you very much, mate. Okay, Joe, nice one, mate. See you Monday, mate. Have a good one. I could do the watching Harry Potter as well. I should watch them all from the start. You know, I don't know, how many hours do you need to watch the entire thing? I don't know. I lost track of it some years ago. It's either I lost track of it or at least it lost track of me. Can't remember. Right, oh dear, what am I doing now? How long have we been going? An hour and 21, that's not much. So, right, so there's this idea with a pin. Now, I don't know if it'd work, but if I keep it the same, just change the shaft out, and we could put some brass. Oh, I've only got M3. Wife says you're really good at what you do and she finds it interesting and wants to watch you again. Oh my god. Yeah, some people watch on their TV, you know. They go onto the YouTube on their TV and watch it on a massive widescreen. Yeah, probably not a good idea. It's interesting though if I don't know, if it gets kids off the mobile or people off the mobile. Doing something else. Stops me eating. Otherwise I just sit here binge eating like this all night. You know. So anyway, so there is that to it. Yeah. I don't know why I do it. Could just go and buy one of these, but I don't know how much a 7-way one is. Let's have a quick look. Let's just have a look how much a 7-way is. Yeah, you're watching on TV, yeah, fair play. I've never done that. I have to put my TV on. Yeah, I've got a big TV there. I ought to watch myself streaming on it. Never done that. It'll be interesting, won't it? I don't want to see me, but I mean, it'd be interesting to see if it works. Like, I'm just going to put a 7-band HF switcher. What do you call them? Switcher for ham radio. It's probably going to just find me, I would have thought. No. Okay. Oh yeah, there's one from. Let's just bring one up. Oh crikey, 400 quid. 80 quid. 7. Let's bring this over here. So what we got? We've got one from Martin Lynch and Sons. Can I bring that up? Open image in a new tab. Can I do that? Oh, it's still small. Never mind. What a shame. Yeah, so there's £135. Don't know what this one is. This is 180. 79 for a flat one. It's got a remote control. That's handy. But hell, I like that. That's good. Remote control. It's got it all. That's exactly what I'm trying to do, isn't it? Let's have a look at that one. Is it? So we've got the feed, and then you got the. Oh. Is it 7-band or 6-band? What's it say? 6-way. That's only a 6-way one. I suppose you could lose 4 meters. I don't know. Right, so you've got what you got here. A four-way one. 6 position. What's that one? Is that, what is that one? 2-way, 2 radio, 3 antenna. I don't know what that is. And then you got this remote antenna. Don't know. What else we got? 400 quid. Antenna switch. What was that? Let's ask ChatGPT. ChatGPT, come on ChatGPT, do your worst. AI, this is the way to use AI, not incorporate it into your operating system. Let's see if it finds anything. So, oh, there's a big one. 213 quid, 600 quid, whatever that is. Manual switching, 8-way manual remote antenna switch. Oh, that one. It's got some kind of control on it. Yeah. I don't know. Right, anyway, so there's, yeah, 200 quid. It's a shame because all it is a load of SO239 sockets and something else. So, yeah, it's made of metal, probably metal, aluminium. Would it be made of metal? Don't know. Anyway, things do exist, but so begs the question: why am I making one? I have no idea. Stops me eating. Right. Anyway, so this does both types. So obviously that'll bend when you switch it. It'll bend and touch the side, but it's, hang on. Do we want it to touch the side of that? Yeah, I suppose so. Let's go up a bit then. So we want that in the centre. So you've got 2 mil there, and you've got 4 mil there. So if I bring that up by 1 mil, is that enough? No, it's not enough. Alright, okay, what we got now? That's better. Yeah, so that sits in the middle like that. Is that right? Yeah, is it? Doesn't look right. Maybe it is. No, it's not quite right, is it? Right, okay, I'll tell you what we'll do. We'll measure that. 1.103. So if I bring that up by 1.103, then I move it down by 1 mil. It should be right, should it? Now? Yeah, it should be in the middle now. Yeah, it is. Right, and I've got to do the same with this one over here. That's too long. I've got to shorten that. I've got to bring 2.103, so I've got to go into this. Grab the whole lot of that. .103. There we go. Okay, and this is too long. Let's bring it, make it smaller. Say 5 mil at a time, see what happens. Let's lose the SO239s. Right. Okay, so that would be a bit of a problem. It's still too long. Let's go another 3 mil. Needs to touch it and bend, but be able to bend and snap away from it. Let's use the mechanical. Yeah. So it touches the side, and if you turn again, it'll bend enough to push round it. Maintain its spring-loadedness, if that's even a word. So you can reach the International Space Station. You can, if you want. I think it's yeah. There's another frequency, VHF frequency for that. I think they use VHF, and you've got to have a little beam, and you have to follow the space station with the beam as you're talking. There's loads of videos of people doing it, and you'll probably be able to contact them or hear them for probably 30 seconds or something. Don't know. So that will be a bend on it. So that will have to be adjusted to whatever you. I can't simulate that, so obviously that will be on an angle and it'll touch that. I suppose I could put that on an angle. I need to make a curved one so you can better visualize it. And you can either press it one way or the other. So when you go clockwise, it'll touch this edge, and when you go anti-clockwise, it'll touch that edge. But either way, it'll snap into position. So this needs to be thin enough to be springy without bending. Anyway, we'll leave that bit. So we've got that idea. Right, so putting back the actuator's the same actuator. So we can go leave it like that or go back to the original idea. Is that an easier way? Now, how am I going to push that into there? That's what we've got to think about now. We've got to make sure that's something can be put into there. So, just wondering whether this needs to be 2 strips and sprung loaded the other way, similar to this wiper, similar to this one, where it's sprung loaded and you press it together and then you push it in and it snaps itself in. I don't think this would work to hold onto the PCB. And do you want these to scrape around the PCB? Imagine them scraping around the PCB as you turn. So this idea seems better. So that idea seems better to me. More of a better fit. I wonder if you can actually get copper M3 fixings instead of brass. Let's find out. Let's have a look. Do copper M3 by 16 pins exist? Dowel pins, standard metric M3. You can readily find metric pins. Copper. There are copper pin shaped parts, but they're usually electrical terminals or tube pins. Why pure copper are rare? Right, okay. What about brass pins? Well, yeah, you can get M4, but I don't know about M3. Yes, do exist. M3 by 16 is less common, so we might have to make it M4. Change the insert maybe on the next one. How does brass pins compare to copper for conduction? Copper is significantly better than brass. Here's the practical comparison. Right, 100% conductivity, 20 to 30% tight. Okay, steel. Right, okay. Would it be any good for ducting RF at HF frequencies? Yes, both copper and brass will conduct HF at HF frequency, but copper is notably better and brass can be good enough depending on your losses budget. We don't want any losses. At HF, skin effect dominates. What? RF current flows mostly on the surface of the conductor, and the key parameter is skin depth. Conduct because brass has a quarter of the conductivity of copper. Alright, so we need can you source M3 copper pins? Right, okay, M3 by 25 copper coated studs. Copper coated studs, right. What are they there? Copper hollow rivets. Anyway, so we're not too sure about that then. Not too sure, so anyway. Right, so we've got both types, just need a way of locking this in. I don't mind printing another shaft out, that's hardly anything. Now these I haven't got, I'd have to put M3 stainless steel. I should have asked it about stainless steel, I got some stainless steel. Tell you what, let's see. Let's just measure continuity on a stainless steel pin. Right, here's an M3 pin. You can't see it. Let's see what it does. Let's have a look at the resistance. It looks like it's 0 ohms. But you've got to put some 0.5, so it's conducting. I don't know, maybe you don't need copper pins then. Okay, that makes it even easier. Makes it even easier. Right, so okay, so I won't use them. We'll paint them silver. Is that going to be it? No. No. No, don't like none of them. Okay. That's even better then, isn't it? It's showing me resistance of the same. I don't know. I would have to do some tests. I'll do some tests. Okay. All right. Okay. Might as well change these as well, because these aren't going to be... If you can't get M3, you can't get M3, and I'm going to pay too much money for stuff you can't get hold of, so just want to make sure you can just get hold of stuff. So, does that even need to be copper? It could be just... And I say copper, I don't know why I say copper, but it could be just like a bimetallic strip or something. Anyway, we'll leave it like that for now. So we've got that, and let's take away the PCB. Okay. And the wiper. So we've got to work out how we're going to make this stay in there. Needs to snap in so you can replace it easy. Right, let's get rid of conductive pin. So, a piece of copper. Oh, we need to attach a wire to it. Yeah, so the wire, this red one is your incomer. So your pin's going to have to come down here to there. And then it's going to have a wire wrapped around it. Enough around it so it can articulate around and then back again without tightening up. So I suppose we could have a pin straight away through there and a flat side either side, and you bolt your ring crimp on the wire to there. Yes, but that might work. So we want a pin all the way through. Yeah, just bolt a pin straight through it. Don't know, unless we put the... I don't know. Don't know. I'll have a think about that. So, all I need is to hold that in there somehow. So I need... Let's get rid of them a minute. Right. Let's put... Gonna make a printer's new shaft that fits this. So we don't need... I don't think we need these things anymore. Let's get rid of these. Can't see for looking. Right, what's going on there? Oh. Okay, that's one way of getting rid of it. So I got rid of that. What do we need to get rid of now? We know we've got 1 mil. So if we have a pin all the way through and it's got attached to... Oh, we could tap it. Yeah, we could make the copper... No, it wouldn't work. 2 nuts either side of it. That would work. Yeah. What about if you screwed them in together and then you could adjust it? Don't know. Alright, let's get this the right height. Hang on. 1.6, so let's get rid of this a bit. .6, right, okay. So we've got it in there. Okay, let's just bring them in then. 1.5. Can I do that, or is that going to be a problem? 1.5. 1.5. Okay, that's a little bit weird, but yeah. I could do that, I suppose. Don't know why I'm doing this. I could just leave it like that, but anyway. Okay, we want one from there to there. One from there to... Oh no, we don't want that one. I want one from there to there. No, that didn't work out. Right, one from there to there. No, that didn't work out. Oh, it did, but I didn't. Forgot to put this one in. Okay. So I should be able to get rid of some of this extra geometry now if we just do that. I got rid of some of it. Can I get rid of that? Yeah, that, and that, and that. Let's just have a look in 3D. Probably get rid of that as well, and that. Okay, so we've just got a slot in there now. So we just slot it in. What holds it in? We need something to hold it in. Why have I got that there? Don't need that. And we don't need that as well. Right, okay. So I need a hole through the middle. Okay. So we can push a copper strip in, we can turn it. It's very mechanical and crude, but if it conducts, it does the trick. A switch is just a piece of copper and a rocker, yeah. Anyway, let's try it. So I need a hole through there. Let's say it's M3, because everything I got is M3. So let's bring back the, not that one, where's it gone? Conductive pin. We'll keep the nut as well. Shall we keep the nut? Or drill and I don't know. Don't know how we're going to do that. Yeah. Let's just get the pin. Let's copy that. Let's rotate it. Like that. Let's grab it from there. Let's put it, I don't know where we're going to put it. Alright, put it there. Is that in the middle? It is, just happens to be in the middle. Alright, we could measure the middle of this. Alright, 2.624. Doesn't seem a lot. Maybe it is 2.624. So if I bring that down, 2.264. Oh, that's no good. So yeah, I wasn't right. I wasn't measuring the right stuff here. Alright, so go from there. No. 2.097 plus 4. 6.097. 6.097. Still not enough. Oh, yeah, to come on to the top, so I've got to go down 2 more mil. Down 2 more mil. That's bang in the middle. Should be, yeah. Right, then I need to come out to the surface. So what's the diameter of this one? 12 mil. So I need to move it out. Six mil. Okay, and then we need the nut out. Whatever. What do we need the nut out? Hang on. No. Come out. No. Where's the nut? Can't get the nut. The nut isn't part of that. How can I get the nut out? Hide the shaft. Shaft. Yeah. Let's bring it out 6 mil. Bring the shaft back. How far away are we? Could do some flat sides to it really, but anyway, for now. 1 mil. Right, is that okay? Yeah. No, it's not. Okay. It's not quite right, is it? Alright, I'll do. So we can need that out so we can attach something. So I've got to make that screw into that somehow. Tightly. So I might have to put some nuts in here and then, I don't know. Anyway, that'll do for now. Right, so we can do it, sort of. Maybe. Yeah, so 4 mil strip. So we could file the strip to go in there or whatever, drill a hole through it. Yeah, it's not brilliant, but it's cheap. Not brilliant, but achievable. Cheaply. Wouldn't it be great if we could get rid of the milling out the aluminium? Anyway, so there's another way of doing it. So you've got room for your ring crimp. You can bolt it down. And you can turn your... Actually, let's get this locked on. Oh, it is locked on. Oh, let's get the pin locked on. Right, so all that'll be rotate in one place. Okay, so you got the idea. So you can snap it. 45. Oh, got more than one knob going on here. Right, that's the other knob, isn't it? That needs to be cut. And put with the other shaft. Where's the other shaft? It's not there. Why is it not there? That's weird, isn't it? I thought didn't I not make that shaft unique? Where's my original shaft gone? I seem to have lost something here. Why have I lost something? Right, get rid of that. Get rid of that. Get rid of the clamps. Oh, have I lost the original one? I think I have. Copper strip shaft. So I hired the copper strip shaft and it's all gone. Ah, I must have forgot to make it unique. Oh well. Yeah, never mind. Right, let's see if I can. Let's see if I can't bend this to fit, even though it's quite thick. Would it be nice? Nice if I can get that to fit on there. Now I wonder if I could bend it round there. Maybe. If I was to screw some fixings to it. Got some fixings here. Got some fixings in here. Can't see what I'm doing. It's probably not gonna. It might hold it still enough to. To bend it, maybe. It's worth a try. Every time I go down there to do it, you can't see anything. Right, let's see if because we said we were going to assemble it on the thumbnail. So I'll put a few of these in. Might be able to do it if I could put the nut on the back. Could have done with scoring it really. Unless I make another one. Don't really want to make another one. It takes too long to sit there monitoring it. Harry Potter. Right, so we've got that there. Now they're not screwed in, but they will hold it in place while I bend it, surely? Will it? Or will it just go move the plastic? No. It's starting to kink it at the wrong position. Right, so I just need a metal clamp. I need to score it. Right, I'll tell you what, take it out and I'll score it. I'll score it both sides with, I don't know what, Stanley knife? Something. And if I score it, I might be able to bend it. So what we want from this project is to be able to make your own, just by buying a bit of hardware. Make your own. Do a bit of soldering. Right, so we've got the strip. Let me see if I can score it. So I've got a Stanley knife, which I sliced my thumb open with it once. And we've got the ruler that I sliced my thumb over with it as well. Was it this one? Might have been. So, how do I do it? How do I do it without slicing my thumb off? Again, which is that one. Can you see the line on it? Anyway, right, that's almost like, that's funny enough, that's the size of the ruler. That's weird, isn't it? Right, so I've got to try and score it. So if I can clamp it to it, yeah, if I can clamp something to it and then use it as a rule. What have we got? Oh, I've got some pipe spanners, little cheap pipe spanners. So if I clamp it with the pipe spanner, clamp it like that. No, it's not going to work, is it? Alright, that'll hold it still, but then I've got to score across it somehow. Not easy. Don't have much in the way of vices. I've got this. I've got this little piece of bracket. I could put that there. Clamp it all in place, then scratch across that. Just needs to be a score. Or do I go and manually run it? I could put a V bit across it. All I want to do is bend it to see if it would fit. So I think I'll go down to the CNC. And the trouble is I've got to glue this. I'll have to put some masking tape on it. Masking tape on the bed. Super glue it to the bed so it holds it still, and then I'll have to position the V bit right where I think it needs to go and just pass it backward and forth manually. Either that or hacksaw it, or make another one and change the way I do it. Don't want to sit there making another one though. Yeah, I don't want to do that because you have to take all the birds off again. So actually I just had a thought. What, you know the tin foil you can get? You can get like these party dishes. Hang on. Let's have a look. Roasting tin foil. Foil in the shape of a dish. Dish. That's it. Some of these are quite thick. It might seem mad. Yeah. It may seem mad to use such a thing. Not this stuff. The thick one. Thick. Think. Thick. Right, yeah, get some Bakery Direct. $9.99. £10. Bulk half size. No, I don't want aluminium. I want foil. Well, it's going to be aluminium, isn't it? Need to be smooth. Thick. I've seen people. Tell you what, forget about that. So, roll of foil. Roll of foil. Aluminium. Aluminium or aluminum. So you can buy a roll of it. You could even do tape, aluminium tape. So if you go back to the model and you put everything on it, the chassis, the SO239s, lose the chassis, sorry, put the plastic clamps on. So basically it's the only thing that needs screening is this area here. So if you was to wrap around a thick aluminium foil, just wrap it round, push your SO239s over it. Yeah, you'd have to cut it around there though, wouldn't you? Yeah, that's the problem. And it wouldn't be hard wearing, but you've got these to protect it. It's just like a jacket. Just be like a jacket. I know it's crazy. Yes, jacket. So anyway, let's go to the next stage then and push these in. Let's push these in and see what happens. So I lose the... Hang on. That top aluminium, where's that gone? Right, let's lose all this. Right. So, what happened to that? Thought that was going to be part of the shaft. It's all gone a bit messy. Hang on. That's a pity. Just wondered, hang on, did I actually save this yet? Let me open, I'll open it up again. Maybe I haven't saved it. I can copy the piece back in. Where's it going? There it is. Let's open this same one up again. Right, so we want that. Save the changes now. Open it as read only, yes. Right. Now let's have a look. Oh, still got it there, that's it. That was, yeah, so luckily it's just a bit higher than where it was, that's all. So we want that. Copy that. Right, get rid of this one a minute. Paste it in place. Right, and this is the original shaft, so we need to change it to original shaft. Where's it gone? There's. Okay, and we're already unique, so we'll just move that down wherever it used to be. The wiper. Oh, where's, oh, there's a wiper, right, okay. Let's hide the PCB. So it needs to move down to there, 8mm. Alright, so we'll get that back. Eight mil. That should be back where it's supposed to be. Yeah, that's good. And I can hide the shaft. Bring back the copper strip shaft. Yeah. That's it, and hide the wiper, so we've got everything back again. Apart from a mess. So I think what we'll do is yeah, let's bring back the original shaft and the wiper. So we're going to make that. So we're going to make that. Going to cut that out. I'm going to paste it in place. Select them two with the cap. Make it a component. Or group it. So we've got that, and the group will be under copper strip shaft. I'll tell you what, we don't want the knob, do we? Let's just undo that. Hang on, undo what we've just done, undo group. So we want that and that as a group only. Okay, and we want... I can't tell whether there's two of them, we only want one of them. So I'll put that up there a minute and bring back this one. Alright, so there is only one knob, that's fine. Let's bring it all back, so make sure there's only one knob. Actuator, yeah, there is only one. Right, okay. Right, so put undo layers. I didn't notice how far I moved it, so I've got to, that's it, put it back like that. Right, so we've got that shaft, we can turn that shaft off. So we've got, where's the other shaft? That shaft we can turn off. No, something's got, yes, turn that shaft off, turn this shaft on. That's it. Now, this shaft, hang on. So the original shaft is, yeah, that's the original shaft. Okay, so when I turn that shaft off, it needs to turn off that, well, I don't know. Need to tie it in with a different shaft. So we've got that as a wiper. It's in layer 0. So we need that to be probably called copper shaft. No. Shaft A, shaft B. Don't know. Copper strip shaft. Yeah, let's call it that. Copper shift strap. I'm probably actually going insane at this point. Right, that's that one. So then we want the normal shaft. Where's that gone? Why have we only got, hang on. We've lost the original shaft now. Where's it gone? Oh, there it is. So it is there, but hang on. Copper ship strap. That's the shaft, yeah. Let's come out one. Copper shift strap. I don't know. I've totally lost it now. So we've got two shafts, haven't we? That's the copper ship strap. strip shaft, and what's this one? Layer 0. Okay, so layer 0. Alright, that's got to be the copper shift strip shaft. And that one has got to be shaft. Where's shaft gone? There it is. So oh god, hang on. Just move that back down to there. Right, so turn off that shaft. Yeah, but we still need the knob. So the original shaft, copper strip shaft, right, okay. Actuate, so that needs to come out of there. Paste in place, and it needs to be just called actuator, right. So you got copper strip, yeah. And then you've got, where's the shaft gone? It's disappeared. There it is. So you've got that one, and then you've got that one. That's it. Sharing the same actuator. Okay. Right, let's put back the base plastic. So you got your base plastic. Okay, right. Okay. So we're going to shrink stuff. Now, is that even a good idea? So we've got chassis aluminium. We're trying to get rid of this chassis aluminium. We don't like the chassis aluminium. But we've said we can't do that because we can't get it low enough for the fixing. So they got the plastic chassis clamps. Anyway, I think we've been going for a bit, so I think that's going to be it because I'm starting to go insane now. I'll have to ponder over it another day. So we could make these two shafts and the pins. Then I don't have to wait for the PCB or design a PCB. It might not work anyway, the old way. So the PCB and swapping the shafts around. This idea might not work anyway. Hang on, pins. Yeah, this might not work anyway. Lost it now. What? Oh, plastics, clamps. Yeah, this might not have worked anyway. I don't like the idea of scraping it across the PCB, even though that's how a multimeter works. So probably if I go for this other idea, this idea instead without the PCB, and have the pins. So we have the pins and this strip that can be built without anything else, and I can measure continuity between there, and somehow we've got to get the continuity for this to screw into this. So I'd have to tap that and make it a real tight fit. Almost tap it, make the hole small and use the thread to tap itself in. Maybe. Okay, so I'll leave it at that for now. So that's the other one, so I'll get rid of that one. So this can stay the same. All we've got to do is screw the pins into them, get a copper strip and print this out again. We haven't actually put a hole through yet, so we need to alter that. So I need to use that as geometry. Right, so that's going to be not so easy to do. Copy. Paste in place. What I need to do is probably make it the same size actually. So if I oh, why is it not doing anything? Right. Okay. So if I make it 12 mil long. Oh, it's got two lots for some reason. Okay, so we've got the pin 12 mil long.
Hello, would you come to that fixed radio check, please? Mike 0 Papa Victor November 0 TDN. Listen for a quick radio check, please.
Yeah, I've gone and made it. What size is that? 3 mil. It's a nightmare, isn't it? Let's just do one. 1.5 mil. Let's make it 12 mil long. Tell you what, let's make it a bit bigger. 15 mil long. Let's get this over to. Come on, you can do it. Put this over here. Right, let's get it out from about there. Get rid of this one. Alright, we need to intersect the faces with the model. Let's just do that bit. Explode it. Intersect the faces with the model. Okay, it's done something, don't know what. Let's have a look what it's done. Let's get rid of that. It's a funny way of doing it, I know, but let's try it. Should have just put a flat face on it, really. It would save all this trouble. Right. Okay. Let's keep going. The only reason I've done this is to get the curves right. Although, we probably don't need the curves anyway. If I'd have made the flat piece. Let's keep going. Gone past the point of no return. Okay. Alright, so we've got should have a hole through it now. Sort of. Apart from this and that. Now we've got a hole through it. Okay, can we... Is there anything we can get rid of? No. Okay, so what have we got now? We've got something here. Oh, I don't want all that. So we'll have to get rid of it manually. I think I need to watch some television. Alright, what have we got now? So we've got 2 holes. We've got 2 holes going right through the centre, and we seem to have okay. Is that okay? Yeah. Alright, so we can 3D print that now. 3D print that shaft. Right, let's create. Let's just go over it. See if anything needs to be smoothed now. Alright, let's print, export it. Okay, and this is going to be called, I called one the shaft. I'm in the wrong one. That's it, it needs to be in this one. So switcher actuator, switcher lid, switcher shaft, there it is. Now it's the switcher shaft copper strip. Okay, let's put this all back together. We'll leave that shaft off. Let's put the base aluminium in and the chassis clamps. And we don't need the PCB, SO239s. We can lose the aluminium strip, and that's it. So yeah, we can retain a lot of the stuff we've already created. So you just got to change the shaft now and add some pins to it, and find a bit of copper strip long enough. This thing looks, actually in reality, looking at something that big. So the copper strip won't be that big, probably out of an old contactor or something. Anyway, let's get it back to as it was. We'll leave the lid off so we can see inside. Right, that's it. Let's get this thing printing. And I'll go and scan around. Got to rob a piece of copper from something. Wonder what. Oh, I'll tell you what I've got. Just the job actually. PCB, a double-sided copper PCB strip. Or you could use it. Yeah. It's not solid, but according to ChatGPT, it only conducts on the surface skin anyway. So it might be able to test it with just a copper strip. Double-sided. I've got double-sided PCB somewhere. Got it all over the place. Got big packs of it. Right, let's just Get this over here. Alright, new project. Import. Right, so we want this shaft again, don't we? What do we call it? Copper strip shaft STL, that's it. Alright, got some weird manifold edges. Okay. So there's the item in the slicer. So that might work. Okay. Right, what do we do? Let's choose the material, ABS. We need to add support. Slice it. Okay, so it's done this support. It turned out it was hard to get this stuff off. I wonder, is there another way of doing it? Support tie tree. Let's try normal. That's better. It's easy to get off that raft is. What's it made now? What's all that stuff? Okay, I don't care. I'll go with whatever it says. Right, we'll try it. Alright, print the plate. 26 minutes, 9 pence of plastic according to that. Alright, it's going to take a while for the bed to heat up and the nozzle. ABS, it has to get a lot hotter than PLA. Right, that's downloading. Let's get the camera on. So I might go and manually score this strip on the CNC. If I glue it down with some masking tape, just put a V bit in, and I'd have to manually maneuver it though. I'll tell you what I could do. I could measure, if I measure the strip, if I measure the alley strip between the two, I can guesstimate the one, and then I can just add an arbitrary amount. That's not the one. Right, where's it gone? It's alright, it's playing silly buggers. Right, so I'll have to guesstimate the first one. I'll have to mark it, put the V bit over top of it. Doesn't want to measure, does it? There. Why does it not want to measure? I want to go from there to there. I want a measurement. It's not giving me one. You little bugger. Oh, because I'm not in it. Let's go in it. Let's try again. From there to there. Nothing. No measurement. Right, let's draw a line then. If it doesn't want to give me the measurement. $31.480. Right, I'll photograph that size. You can't see it, it's down the corner. Oh, you can. $31.480. You're very noisy, and signal strength is low, but you could be miles away. Right, so get rid of the strip again. So what I'll do is I'll get on the CNC, eye it up manually, and then move it back by that amount, and just pass it over. Could do it automatic. I'll sort something out. Right, what's this doing? Cleaning the nozzle. So it's got to get up to 239 degrees. It's going up at the minute, and the nozzle's the right temperature. It'll have to beat in order to clean the nozzle. Anyway, that's the knob. The knob I printed, and there's some of the other keeps. I've got if you go on online models and search for ESP32 node MCU, it should find one of my model. There it is. This is one I made and shared it. 27 downloads, 14 prints, 13 likes. Don't know what that is. So I made a breadboard for this. You can get them, there's loads of breadboards, but I made mine smaller because most of them use a lot of plastic. So I shrank mine down. I put a power rail down the middle. I've got it somewhere. Where is it? That's the point. Where is it? God, too many. They're everywhere. I can't find it. Never find. Oh, there it is. Oh, this one. There it is. I found it. There it is. It's alright, isn't it? It's nice. I bought these, and they come with these middle strips, and put it in and push your MCU on top of there, and it doesn't use as much plastic as some of the other ones. Anyway. Alright. Yeah, so I could share some of this stuff on here. You know, some of these other stuff I can make it public, but just wait till we got a working thing, really. You know, and all you got to do is get your brass pins and inserts, order yourself some SO239s. Oh, tired now. Anyway, time we got? Oh, still early yet. So that's doing some auto bed leveling, so we'll let that carry on for a bit. We'll leave that alone. Now let's just take a step back and look, is this feasible the way I'm doing it? Hang on, where's the... I keep moving. Where's it gone? Lid plastic. This hang on. This program, it shifts stuff around. That lid plastic was up there, so you're looking for it, you think, where's it gone? And all of a sudden it's down here. So it makes it drives you insane, basically. It makes you second guess yourself. Yeah. Yeah, I'm going to ask ChatGPT about that. It'd probably say, yeah, it's a known problem. SketchUp, make 2017. My layer keep reordering randomly. See what it says. This is a known behaviour and annoyance bloody two writers annoyance. The layers panels in that version will sometimes resort or reorder itself automatically, usually alphabetical after certain actions. It's not truly random. It's triggered by internal refresh events, but it feels random. Here's what's going on. You create a deleter layer, you toggle layer visibility, you switch scenes, you reopen the model. Sometimes when it refreshes it resorts the layers, ignoring your manual ordering. Unfortunately, manual layers was not preserved reliability in later versions, until later versions. So if you carefully arrange layers in custom order, Assembly doesn't remember it constantly. Yeah, so anyway, I use an old version. I use an old version because it's free. But it will crash unless you turn off autosave. Make sure you go into your properties, wherever, preferences, and files. I don't know where, somewhere it is. Click style, general. Create a backup and autosave. Turn those off. If you don't turn them off, it'll crash out. Depend on your graphics card, but on me, different computers, it kept doing the same thing. So annoying. Automatically check the model for problems. Automatically fix problems. Right, don't know what that is. Warn of a style change. So you basically can't cope. Well, if you're doing something in the model and it tries to save at the same time, it causes a crash. Yeah, turn off the updates and turn off all that other rubbish. Warn of style changes when creating scenes. Anyway, that's if you wanted to get it off archive.org, download it and install it. You can. It's still there. I'm sure it's still there. It's not on SketchUp's download site. They've took it off. Took it off because they're trying to promote the ones. They've suddenly decided that you've got to pay for it. A while back, a few years ago, you've got to pay. They want money. Give them money. Yeah, even though the technology hasn't really changed since it came. Let's just Google the. I'm going to Google something. It's just interesting. Sorry, not Google. ChatGPT it. Can you list the chronology? I can't spell. Chronology of SketchUp, detailing the creators and companies who purchased it. Or companies who bought it, or the rights. If you know what I mean. Well, I don't know what I mean. See if you're clever enough to know what I'm talking about. Here's a chronological history of SketchUp focused on its development, creators and changes in ownership. SketchUp timeline of development ownership. 1999-2000 origins and creation. Last Software is co-founded by Brad Schell and Joe Esch in Boulder, Colorado. August 2000 Last Software releases SketchUp publicly as an intuitive 3D modeling tool designed to be easier to use than traditional CAD software, appealing to architects, designers and hobbyists. 2000 early development by Last Software. SketchUp rapidly gains popularity for its user-friendly interface and push-pull modeling approach. Product wins early accolades in industry shows and exhibitions. 2006 2012. Google era. March the 14th, 2006. Google acquires Last Software primarily to integrate SketchUp with Google Earth, enabling users to build 3D models of real-world locations. 2007-2008. Under Google, new versions are released. SketchUp 6, 7, 8, including free editions. 3D warehouse integration, layout tools, geolocation features, closer tied with Google Maps and Earth. Google provides a free version to expand access along a paid pro version. 2012 present. Trimble Inc. ownership. 1st of June 2012. Trimble Navigation, now Trimble Inc. acquires SketchUp from Google. Trimble is a long-established technology firm focused on geospatial positioning, surveying and construction solutions. Under Trimble, SketchUp continues to evolve with professional features, integration with Trimble Connect, support for extensions through the extension warehouse. SketchUp gradually shifts to a subscription-based model with different tiers: free, shop, pro, studio, and a long ecosystem including web and mobile access. Key people and entities in SketchUp's history. Founders, early leadership drove the creation, built it first, custom. Purchased SketchUp to extend, Trimble. Summaries. Want to know timeline where SketchUp stopped becoming free. Here's a focused time that SketchUp stopped being truly free. That's when the full free desktop app either ceased being offered or was replaced with limited paid models. SketchUp free to pay time 2006. Earlier, SketchUp existed as a paid and trial based product. There wasn't a permanently full free version yet. Google era. After Google bought Lasso, Google released a free downloadable SketchUp desktop version alongside the paid Pro. This free version was intended to encourage use and integration with Google Earth and Maps. Trimble begins changes. Acquiring SketchUp from Google. Why would Google sell SketchUp? What was the matter with those people? Trimble continued offering a free desktop version, which became known as SketchUp Make. Make allowed personal use after a pro trial period ended and was the last free full desktop version. That's what I'm using. November 2017, end of free desktop app. SketchUp Make 2017 was released in November 2017 and was the last free desktop version that could be used without ongoing payment. After 2017, Trimble stopped releasing free desktop versions. All new desktop releases were paid and subscription only. Post 2017, free web version only. The web version is crap. With the end of Make, Trimble uses SketchUp free, and you got to make your models public and everything. The web free version is far less capable than the old free. 2020 subscription model fully enforced. There you go. Trimble stopped selling perpetual classic licenses completely and moved entirely to subscription only pricing. You can still use older perpetual licenses you already own, but can no longer buy them or renew maintenance. Key milestones in free availability. SketchUp free web. That was a nightmare, that stuff. Important clarification. SketchUp Make 27 remains available for download unofficially or through archives, but Trimble doesn't promote it and doesn't update it. SketchUp free web, don't bother with that. SketchUp perpetual license, pay money. Last free version SketchUp Make 2017. That's what I got. Yeah. Why would Google sell SketchUp? For a mix of strategic, financial, they don't need no money, and organisational reasons. The short version is SketchUp no longer fit Google's core business goals, even though it was popular. Google's original reason for buying SketchUp criteria got for 3D City. Why SketchUp became less important. So how can a company buy a product is available for free and change it to subscription model after suckling millions of users with it. I was going to say about that then. Yeah, this is one of those classic how the tech world works. It can feel a bit unfair at first glance, but legally and practically it makes sense once you understand ownership versus access as a business strategy. Let me break it down. Yeah, owning the intellectual property, yeah, but they bought it off someone else. The poor guys. Alright, to me, it seems that nothing of note has been introduced from the initial version 7 days. Get that you're saying from a feature perspective, it can feel like it hasn't fundamentally changed in decades. The core magic hasn't changed. The thing that made SketchUp revolutionary was push-pull modelling. Incremental changes. There's no changes. Ecosystem. They won't let you on the extension warehouse. You've got to sign in and be part of their ecosystem. Yeah, that's the problem. I'll go back with computing right back to dial-up modems, PC's first use. So they take something that everyone likes and then they make it a subscription model. It's crazy. Can the current owners stop me using Make 2017? No, Trimble cannot legally force you to stop using SketchUp Make 2017 once you've downloaded it and installed it, but there are a few important caveats to understand. Let me break it down. You can keep using it offline. SketchUp Make 20 was the last free desktop version. If you already have it installed, or if you have the installer, you can use it indefinitely on your machine. There's no built-in kill switch It doesn't require online activation after initial installation. Yeah, you won't get updates. Who wants the updates? They haven't done anything to it anyway. They haven't done much. They've kept the same ideas. Some online servers may not work. Yeah, you can't connect to the 3D warehouse. They shut that off. Rotten pigs. Legally, Trimble could revoke lives for paid version, but not make 2017. Yeah, they took it off their download, so you got to get it off a third-party site now. Anyway, right, that'll do for that. Yeah, so get yourself SketchUp Make 2017. There it is. Forget the rest. Now, at least you know there's no AI built into it. Anyway, let's see what's going on with this. Oh, there we go. It's printing it. 9 minutes left. Oh, we don't want to see it anyway. Right, so that's doing okay. I did clean the bed earlier with isopropyl wipe, so it's sticking okay, and the ABS sticks a bit better than PLA because it's at a higher temperature. Right, anyway, so where are we going with this thing? I think that's it for one day. It's come up to 3 hours, so 2 hours 57. So we'll leave it at that. So I'll do some more work. We'll come on tomorrow sometime with it. Maybe a finished thing, you never know. Got to try and finish it off. Got to get on with another project at some point. If it works, I'll do some continuity tests. Do some continuity tests and get this thing, get this wrapped around here and fastened up, and change the shaft for the different one. Put the pins in. And then I've got to create a belt-driven pulley wheel that'll go onto a stepper motor that'll somehow we've got to synchronise it up. So we might have to put a on one of the keys, put a bracket or something that'll stop it going, so we can use it as a home position. I don't know, that's the thing itself. What does it compare to? Let's compare it to a Radtel 950 Pro. There's your 950 Pro, so it's small, both the same. That's it. It could go smaller, but not a lot. Right, that's going to be it for today. I've got to go and watch a film. See you again. Bye bye. Thanks for watching, and I'm out of here. So that's the 7-band HF antenna switch here. Exoskeleton aluminium. Not quite built, but we ran out of time. But next time you see it, it should be built with a bit of luck. Bye bye. See you again. Bye bye.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.